Hello, and welcome to this episode of GovExec TV, Cyber Fortress 2025, AI-enabled Edge and Cyber Resilience, brought to you by GDIT and AWS. I'm your host today, Heather Caldell-Ware. Each year, the Cyber Fortress brings together government, industry, and academic partners to test the resilience of our critical infrastructure against cyber and physical threats. This year, the Virginia Army National Guard collaborated with GDIT and AWS in a live simulation that imagined a sophisticated cyber-physical attack on the Commonwealth's power grid. At the center of it all, a cutting-edge AI-enabled solution called Dogma, the Defense Operations Grid Mesh Accelerator. Could Dogma be a game-changer for cybersecurity? Can it enable warfighters and first responders to turn raw sensor streams into actionable decisions in seconds, even in denied and degraded environments? Let's find out. In today's episode, we'll explore how AI is driving mission outcomes at the tactical edge, the flexibility of Dogma's modular architecture, and why collaboration across sectors is key to cyber resilience. Joining me is Major Andre Slonopas, Operations Officer, IOSC, Virginia Army National Guard. Thank you for joining me.
Thank you so much for having me.
Brendan Beam, Senior Director for AI Defense, GDIT. Thank you, Brendan.
Thank you, Heather.
And Keith Johnson, Technical Director, DoD Business at AWS. All right, thank you for joining me. All right, I'm going to dive right in with a question here. For those of you who aren't familiar with Cyber Fortress, could you, Andre, start us off by describing and explaining to everyone watching what Cyber Fortress is and maybe how it even came to be?
Yeah, absolutely. It's got such a rich history. I don't know if I want to go back all the years, but really, Cyber Fortress has been it's been a brainchild of several general officers, within the Virginia National Guard, and I can't take any credit here. The idea was born out of a really good mentor of mine, but anyway, he's still in uniform. But what we were observing is that we were a little bit siloed. The DoD was doing the cyber defense, the critical infrastructure were doing the cyber defense. You had the industry, everybody was siloed, but nobody was really synergizing and synchronizing, our defense. Whereas if you think about it, we're all intertwined, right? And that's kind of the reality of things. So that's how the Cyber Fortress was the idea was born. How do we bring all the stakeholders together for joint, combined national defense? So this idea was born in 2021, I want to say. Please forgive me on the years if I got them wrong.
Close enough.
Close enough. And then it has grown, right? I think, and please forgive me if I get some of these numbers wrong, but I think we had about 9 or something like that, or 15 people in the very beginning. And we had absolutely nothing, right? And that was a really, really interesting and challenging time. We weren't sure if it was going to succeed. But fast forward 4 years, the relationships that we've been able to build, especially with GDIT, AWS, other industry and academic partners, has been phenomenal, which is what you've seen culminating actually in Cyber Fortress 2025. So to give you a little bit on the structure of the actual exercise, what we realized is coordinating 600, I think we had about 600 people on the site this year. We have about 900 people on the actual distro list. Coordinating 900 people for 600 of them to actually show up is like, I kid you not, it's like being in a childcare from nightmare, right? Everybody comes in with their own ideas, what they want to do, what they want to see out of it, right? And synchronizing all of it is extremely difficult. So that's like the big piece. But then we realize that just having operators on site doesn't solve your problems. They're only going to execute what they're told to do, which is when we have to bring the directors. So now, not only do we have to bring the operators to actually do the work, we have to bring the decision makers. One bad decision, they get fired, right? And so, but we give them this fail-safe place, you know what I mean? And Cyber Fortress is essentially we give them a place, go ahead and make the decision, fail, because nobody knows unless we go on GovExec and we tell them about it.
We would never air that, no. But so you have people getting the ability to practice in a safe space,
Correct.
Right? Whether they're operators or decision makers.
Correct.
All right. So Brandon, I would love for you to tell us a little bit about your role in the event.
Yeah, so, GDIT brought part of the Dogma solution. Our partner AWS had half of it, and we have the other half. So what we do is we realize the art of the possible and execute the ability to action data once we get it off the objective. So Dogma is really 2 parts. The first part of it is the transport of the data. The other part of it is realizing the value of the data once you have it. And so what we did was we worked to integrate not only counter-UAS sensor data, but also cyber sensor data and advanced tactical power grid data So working with microgrids and being able to identify resiliency. So one of the aspects was being able to power a sensor with a micro tactical grid, but also being able to predictively identify when and where that battery may go down so that we don't lose the sensor in and of itself or the rich data that we're collecting from it.
Why is that prediction element so important?
Well, having the ability to predict when and where something will happen allows us to affect the end state of what that event will realize. And in this case, it gives us the ability to affect that outcome.
Awesome. So Keith, how about your role?
Great. Yes. So, as Brendan mentioned, we are partnered with GDIT to bring the full Dogma capability. Our role is to create the infrastructure and connectivity back to the cloud, which included a software-defined kind of network as SD-WAN, as well as the capabilities to train AI models in the cloud and then push those to the edge. And so we're kind of demonstrating how the cloud isn't just about big data enterprise processing, but how the cloud helps on edge type scenarios. The other thing that we were doing for Andres is providing the cyber range to help train the 600 or so operators on kind of operational technology, IT, cyber defense. And so historically, that's been done with kind of physical hardware, which is expensive and hard to scale, particularly up to like 600 people. We were able to provide a scalable, flexible cyber range environment in the cloud that also connected to operational technology like power systems to enable training multiple people at once. And it's also can be stood up and shut down within hours. So you're not paying for that whole expense when you're not at Cyber Fortress.
And this is such a great point. And actually, like I'll go just a little bit further on this. One of the issues we had in the past is actually defense of the United States does not lie in the United States alone. We have a lot of things that are outside of the United States that actually rely on the defense of the United States. I'll give you an example. So this year we had NATO partners on the system as well. In the past, we had so many issues that connecting NATO partners and allied partners in general into our DoD platforms, but this year AWS enabled us to do that, right? So now what we're actually observing is we're observing certain attacks in Europe, and we're only expecting that at some point they trickle down to the United States. So as you can imagine, the defense of the United States does not start in the United States. It starts somewhere in Europe.
You're seeing what's coming way before it gets here is what I'm hearing, right?
That is correct. Yeah.
That is amazing. So Andre, I'm going to stick with you. So Cyber Fortress has grown year over year. What is different from this year, or what was elevated about this year's event, and why was it important?
Yeah, and that's a great question. I think this year, especially with having a lot of the industry partners like AWS, GDIT, some of the other ones like the microgrids, and also a lot of the other systems, sensors that we've been able to bring, I think this is what is unique. This year, we've been able to integrate 600 people, but they came from 45, I think, or 50 different federal agencies, state agencies, allied partners, industry, academia, research organization, DARPAs. It's been such a mind-blowing experience, but all of them are operating on the same platform. We've been able to really, really combine, and we really struggled with that in the past until this new solution, the cloud-enabled solution has kind of emerged. Yeah.
And just I'll highlight that, folks like DARPA and other performers, months beforehand, they were developing systems and capabilities. They were doing that on our cloud as well, so that they all understood how to run on the cloud. So when we came together, there wasn't that kind of learning experience of like, oh, how do I import this and get it all running? It was all running kind of already. And so we could really hit the ground running.
That sounds amazing. So Brandon, I'm going to pick on you for a minute. We understand that Cyber Fortress was a big event, a big test for Dogma. Could you explain to me and the audience what Dogma is and what role it played at the event?
Absolutely. I think we touched on a little bit of this earlier. I got a little ahead of myself. But Dogma is a fusion of technologies between resilient transport for contested environments and AI and machine learning to enable shift-left decision authority and to reduce the cognitive burden for the warfighter. So for us, it's not just about getting the data off the objective. It's about operationalizing it and exacting those decisions at the point of presence and the time of need that they are required. So Dogma realizes the ability to fuse not only data and sensors, but requirements. And I think we saw that this year at Cyber Fortress with being able to, and I don't want to coin a new term, but let's call it exercise at scale.
Okay.
Right?
We can coin a new term here. I think that's what we're here to
exercise
do.
at scale, bringing those requirements and everything together, but then operationalizing those through a unified architecture. And that's really what Dogma is all about is we don't care what the sensor is. We don't care what the requirement is. We don't care who the user is. You bring it to the fight and we will put it together.
That's great. And so from a technical lens, what lessons did Cyber Fortress provide for deploying AI in degraded or denied environments? And how did Dogma perform? I'm going to pick on you first.
Yeah, no, absolutely. And I think this is actually one of the big things that came out of Dogma. So that project on AWS, we actually call it Capstone, which is the foundation, and Dogma is essentially the big portion of it, right? But it enables us to fuse sensors not just in one domain, across all domains. So I'll give you an example of the things that actually we have successfully done in Cyber Fortress this year. We had counter UAS radars, mind you, developed and deployed by organizations that never met each other. But they were.
That's a big deal.
But that's a big deal.
Yes.
And this is going to be the reality of the United States. You know, you're going to have people developing technology and they don't necessarily talk to each other. There's just so much stuff out there. But through Dogma, on an AWS platform, we made the sensors talk to each other. So we actually had a SHORAD radar that was talking to an Air Force Research Lab prototype all in real time, looking for UASs that we had from a third party. Now think about what you could do here now. Now you can tie Department of Corrections, Department of Defense, Department of Homeland Security. You could tie all of these sensors together for truly like a golden dome type of a solution.
Exactly. And I think one of the important aspects there, right, is now we extrapolate these different requirements and we build these information domains. So one of the things we were able to do is operate with brevity. So when it came time to actually set up, as Andre had alluded, you know, we have all these different stakeholders that are bringing different things that have never talked before. That use case we set up in 5 minutes from hitting the ground. So from the time the sensor was powered on, we were able to actually link them together in roughly 5 minutes. And what that does is it breaks down silos immediately, right? And in this specific use case, you know, not only looking at the UAS picture, but because we were able to set up these information domains and boundaries and bound the confines of those, we were able to put tipping and queuing in, right, that allowed us, again, to reduce the false positives by ensuring that we're only focused on those things that really matter. So if you think of that from the domain perspective, critical infrastructure is extremely important. And when we're fusing cyber information and everything else, we want to ensure that the tipping and queuing that we're getting is actually attributed to what we view to be the most critical aspect that we need to focus on.
And just double clicking on brevity and standing up capabilities very quickly, what we are also providing is like infrastructure as code to not only connect the sensor systems together, but connect that resiliently in a local kind of mesh network and then resiliently back to the cloud, so that if anything gets severed, whether that's a local connection or a connection somewhere between us and the cloud, we're continuing to operate without a hiccup. And we think that's really essential because when you're fusing data together, you need to use the compute that you can, right? And so if you have access to the cloud, you want to use that compute to create better AI models from new information sources that you're getting, like, you know, really boots on the ground data that you're getting right away. Put that back in the AI model, and then push that back down to the edge. And then if you are disconnected, operate locally, right? And so, but then flexibly be able to connect back once you establish the communications. And so, but to do that is infrastructure as code. So you don't need people to go find those turning the wrenches in order to connect back circuits. That takes time, right?
No one's running a cable.
Nobody wants to run a cable. We want to focus all our people on addressing the mission use cases.
I love that. And I just want to, you said it takes like 5 minutes to set up. Yeah. I'm not sure, should I ask you or Andre, like how long did it used to collect all these sensor data? Like, was that like a whole day task, a week-long task? Did it never happen?
Well, I'll say most large-scale exercises start months out in that integration. And we've been able to architect in a way that we're able to do that very quickly, which was, evident at the exercise, which is, again, as Andre said, it's a proving ground. You bring a requirement, an idea, and they allow you to test it. And that was one of the things that we really wanted to test when we got there, is how quick can we do this? Other times before, we've done it in 30 minutes from power up. That's been our average, but we were able to actually pare that down to about 5 minutes. And then even beyond that, because we were on the theme of, doing more with less today, we wanted the ability to be able to auto-train those machine learning models that Keith talked about in real time. So as we detected drift and being able to collect from the various sensors that we were at the exercise, we're actually able to execute that as well, where we were orchestrating the auto retraining of those machine learning models based on real-time data drift.
Yeah. Did you want to weigh in on that?
Yeah, and what I'll say is just from our experience, because Cyber Fortress, this is the 4th iteration that we have done. In the previous iterations, we've never been able to integrate things. As a matter of fact, we went back to an organization that supported us. I'll keep a little bit anonymous here, but they said, look, if you want to bring this much equipment, you're going to break our system. And we said, all right, well, what do you think is going to happen in the real world? We're going to bring more. This is just an experiment. Let's make it happen, right? And this is where really the team from AWS and GDIT and then there were many other stakeholders, obviously, but this really came together, and we've been able to demonstrate something very revolutionary here.
I love that. And he kind of queued me up for my next question, Keith. So during Cyber Fortress simulation, connectivity was intentionally disrupted. So how did AWS help extend Dogma's AI pipeline to function in denied, degraded, intermittent, and limited environments, or DDIL for short?
Yes. So the local kind of SD-WAN infrastructure that we put together operates kind of locally, and it has multiple communications channels. So there's mesh networks, MAN-A for short. There's 5G. We operate under with a Starlink or soon to be Kuiper network for Satcom. And so we have that kind of local connectivity. And so that provides some resiliency at the edge, right? And so that allows sensors to communicate with one another at the local area. And then when we do have connectivity, then they can push that data back to the cloud. We have IoT or infrastructure, Internet of Things device service level capabilities that allow you to sync, whether it's software updates or AI model updates, when you do establish connectivity, but then when you don't, they run locally. And so we all know that we have to be able to run at the edge disconnected, because you never know, right? But our belief is that's going to happen, and then we want to be able to establish connectivity quickly in order to then pull that data back, identify new insights in that data, and then push back, new models, new TTPs that can be executed at the edge. And so the IoT services, the SD-WAN capability as infrastructure as code that we built, and then working with partners to kind of instantiate that into unique capabilities that really affect mission is kind of what we see as our part in how you work at the edge.
Everyone's nodding. Did you want to add in on that?
Yeah, well, I just, as I hear all the conversation, it just reminds me, of how we build today, right? We have to build for the edge, and that's what Dogma is built for. But to Keith's point, right, it's like owning a Porsche, right, and driving it here in the DMV. You never really get to open it up. You still own the Porsche for the luxury and having all of that horsepower and everything when you need it, right? And if you architect that at the edge, right, you get that luxury car in every condition. But you know what? When you're out on the A8 and the A10 in Germany and you really want to open it up, then that's when you have the ability. And that's what Dogma's for.
All right. So AI at the edge, the Porsche version. Yeah. Andre, did you have other thoughts?
Well, so I don't know how I'm going to top that.
I don't know.
That Ferrari, analogy here. But, the edge is such an interesting thing here, but the edge, you have to deploy, and this is kind of my understanding a little bit, working with some of these edge devices, you have to deploy systems that have been, kind of connected and trained, and before they get to the edge, right? Now, how do you get there? This is why the Cyber Fortress and events like this are so important, because you're bringing so much data together, so many stakeholders together, with everybody having their own interests, invested objectives that they want to get to. But when you bring it all together, train the models, and then deploy them to the edge, now you can have a Porsche that turns into a Ferrari. Who knows? You know what I mean? Now you can really open it up.
This is the car portion of the segment. No.
Yeah.
So we've heard about AI at the edge a lot, and it does usually sound a little bit more like a future state than what we're doing now. But what strikes me is this exercise. It's real. It's not what's coming. It's what's really happening. So I'm willing to hear from all of you. What's your biggest takeaway from making AI operational in a live, multi-domain mission setting? Keith, I'm going to let you go. You're going to have the hardest one because you're going to go last.
Right. So what I think we've learned, what I learned in this exercise is, the cloud is a part of the edge. And Brendan mentioned this earlier, the update cycles are very important. When we're dealing with any adversarial threat, right, we can assume they're not going to be static in how they're going to kind of confront us. They're going to change things up over time, right? If you have a static like AI model or any system that's already been trained to address a certain set of tactics, techniques, and procedures, or TTPs from an adversary, that works as long as the adversary doesn't change their TTPs, right? But we know that's not reality. Whether it's cyber defense or even kinetic defense, there's going to be different modes that we're going to have to learn how to address, right? And so as we collect all this data through a dogma-like system, and then when we have connectivity to the cloud, we are able to bring that back, update all our models that are countering activities, and then pushing that back. That symbiotic relationship is very, very important. And just like, for example, on an exercise we worked with GDIT, over one day, we updated an AI model like 38 times within like 12 hours, right? Because that is the pace of updates and how we need to operate going forward. And that requires kind of resilient communications and connectivity. It requires kind of cloud-enabled AI model generation. It requires the updating capability, and then the end systems like Dogma that can use that to affect a positive outcome in defense of the country, the area, wherever our forces, troops, organizations are going.
Brandon, your thoughts?
Yeah, so I think we touched on it earlier in the discussion as well. Anytime you think AI at the edge, it's all about breaking silos, right? If we are trying to integrate the multitude of sensors that we have, the magnitude of data that is coming at us, it's not going to slow down. If we look at what's happening in the eastern flank today, if we look at what could potentially be happening, in the Indo-PACOM AOR, data is going to be the driver of necessity, and risk is going to be determined by how much we can mitigate at the edge in a contested environment. And it takes AI to do that. So for the sake of using AI, right, we need AI to be that mission enabler and to reduce the cognitive burden on the warfighter, definitely moving forward, but today more than ever.
Yeah. Andre, your thoughts?
Yeah, I'll say I'm a firm believer in AI. So I publish on it fairly heavily now. I understand there's a lot of conversations that keep going back and forth, but I think we've kind of turned the corner in the global affairs where we're not going back to the world before AI. So we have to figure out a way to capitalize on it, really. And I believe on the edge, AI on the edge is a way to capitalize on it. So I'll bring a couple examples, a couple lessons learned maybe from Cyber Fortress. But there was a great study that talked about the success rate of the red teams compromising the blue teams. And if you were leveraging AI, I think the success rates went up to like 70. Right.
That's distressing.
That's distressing. And so one of the other programs that we actually had at Cyber Fortress that we were testing, within 5 minutes, it could execute about 10 years worth of labor hours for a human being. So think about how big your team has to be to counter one machine. Now, what if you hook up 3 machines? That's the entire cyber force of the entire United States. Who knows? But it's impossible to counter that. So we have to arm people with AI to essentially counter AI. It's a really interesting time to live in, right? So with Cyber Fortress, with the emergence of AI, and we kind of have been able to demonstrate, I'll give you some numbers here. We've been able to reproduce what 35 human beings do in 8 hours. We've been able to reproduce with 3 human beings in 30 minutes. So think about that. So then, you're essentially, I don't want to say you eliminate the need for work. No. And that's the argument I made. And I was like, oh, we don't need all these people, right? But the comeback was, no, we can do more with the same amount of people. And that is the reality of things. Now we can amplify the human potential. And in Cyber Fortress kind of demonstrated that with our partners, obviously, but I don't think we're going to shift away from AI. I think we have to figure out how to use AI, how to train and make sure we have the proper algorithms operating, and then how do we push it out to the edge? And that is, I believe that is the direction we kind of need to head towards in the very near future.
All right. So, Brandon, I'm going to pick on you for this one. We've already mentioned flexibility several times, but why is it so important when applying AI to real-world infrastructure and cyber challenges?
Well, no two use cases are the same. AI typically is trained for a very specific purpose. In this day and age, we either have to have multiple AI models trained for multiple purposes and orchestrate which ones are used for the specific use case. But the reason it's so important for versatility and adaptability is that the situation constantly changes. So AI needs to constantly change as well. It's very tough for human beings. A lot of us, organizational change management is something that has a whole degree wrapped around it.
That's true.
And it's very difficult, right, for people to change. And so the same happens when we're in an environment where stress is elevated, right? The conditions are elevated. It's very difficult to go off of your muscle memory. Rote memorization and muscle memory are what take over. The same thing happens with AI, right? We have to test it. We have to pressure test it. We have to prove it. And the way to be versatile is to be versatile in the way you're using AI and the AI that you're using.
So AI isn't a siloed tool, it's the connective tissue. Can you explain how Dogma helped fuse cyber intelligence, surveillance, and reconnaissance and kinetic threat intelligence during the exercise?
Absolutely. So the fusion itself, we built and orchestrated an engine that will read in using more machine learning applications. A lot of people confuse machine learning and AI.
That's a different discussion.
Yeah. But using machine learning, we were able to schema translate on the fly, which means a sensor comes in and they may be pushing data in a very specific format. We can infer that format and then translate it to a format that's usable for us. That was the integration piece. But beyond the integration piece, we were using generative AI and agentic workflows to allow the operator to use a chatbot that would allow them to make sense of that fused information, whether it was affecting something in the scope, saying, hey, I need you to, generate a named area of interest around this specific geo-referenced area and create alerts, then the bot would actually do that. So under the hood, we have a lot of AI that's used not just in predicting where a UAS will be, but how we actually affect the outcome and the visualization and the end result of what that prediction provides. But for us, breaking down the silos really comes into, it's not just about saying where something will be, or having AI for the sake of AI. It's how you're actually using it.
Did you want to add to that?
Yeah, I think, I think that was a perfect answer. Not much I could add to it, but yeah, no, using the AI for the right purposes. And people think about AI as like, there's like AI, right? But it's such a generalized way of looking at things. But like you have AI for pedagogy, you have AI for cybersecurity, you have AI for cybersecurity of ICS systems, and SCADA is a little bit different than, AI for cybersecurity of like a network system. So I think like these use cases are so unbelievably important, right? And how do we cut the lowest hanging fruit to demonstrate the value of it, right? And then the next thing is like, how do we deploy it? And if I could bring you one more example, and again, I'm going to keep things just a little bit anonymous here, but the budgets of some of these organizations that we work with, they're so limited, they can't hire more people. But now when you arm it with AI, that could be really, we're talking about pennies on a dollar, and they went from 2 people to 200 simply because they got some sort of an AI tool and they have people that are trained on it. Now think about the power of that.
Oh yeah. And I think that scale is important. And just to provide a metric, I deployed 1 person to Cyber Fortress.
Okay.
So I had one individual.
Whole 600-person exercise.
For the AI portion.
You had one?
We had one as well. Yeah.
So you had 600, they each had one.
598. 598.
598.
Yeah.
So, but let me just, if I could just, the
please do.
importance of the human element, I think we need to just make sure we're double clicking here as well. AI is not going to like just do everything or be autonomous. And a key part of Cyber Fortress was the training element. It's like, how do we train our forces, whether it's a workforce or a cyber defense force, to operate using new technologies? And so, I really commend Andre for really thinking big with Cyber Fortress and really saying how many people can we train. And I hope we're doubling it next year. I don't know how we're going to do that, but we need to train more people on how to use AI effectively and bring them along. And so there's going to be, the curve of those early adopters, and that's fine. We already know that they're going to use AI. The key is the middle to back portion of our workforces that are a little bit skeptical still about, is it going to steal my job? How do I really operate? I'm a little bit concerned. We need to bring them along, and things like events like Cyber Fortress bring everybody along, and that's what we just need to do in general. The workforce is important, and AI enabling them is a key area. We're going to invest a lot of money to invest to AI enable workforces across all industries, because it's just such an important activity for our nation. And so I commend Andres for just thinking about that at scale, and let's keep going. Let's figure out how we can do more next year.
So I love that you sort of co-signed the training element. And I'm curious if you got a lot of feedback from the people who were actually the operators and the decision makers. Were there something that they came up to you like, I can't believe we were even able to do this?
Yeah, 95% of the feedback I'm getting is extremely positive, right? So I have federal, state agencies, I have industry, academia. They're reaching out. They're like, hey, what are we doing next? Let's start thinking about this. And what I will say, a little bit of a preview, we're going to go national, right? So at the moment we've been kind of state, regional. We're going to go national for next year. So I think we can get to very good numbers. But it's not just about numbers. It's essentially getting to the right, right and relevant training environment. I think that is more important, right? So, and one more comment I wanted to make about AI, because you make such a great point, and I hear this all the time, AI is going to take away my job. No. AI is going to make you better at your job. That is what AI is. It's not taking away jobs. It's amplifying what you can do at your job. That's the way I see AI. But anyway, just my thoughts on that. In regard to the feedback, positive 95% of the time, right? People are a little bit, I would say, shocked even. They've been able to host this on a military installation with industry, academia, professors, AWS, GDIT, the federal government, the state government. Generally, that doesn't happen. And because of those silos, we've been able to break that down. So that is one feedback that I get. But I do want to touch on that 5% negative as well, though. One of the things that has sort of come out is like, well, why are we doing this if we haven't maybe gone back to our roots, and why haven't we gone to a little bit more classical, approach to training and doing some things, and why do we need the whole of government to respond when it's a DoD exercise? So there is feedback like that, but I'll say that it's a very, very small minority. And my counter argument to that is, well, we're fighting as one nation. I mean, if you look at World War II, right? I mean, somebody was building the ships. They weren't in uniform.
Fair
but
point.
they were, you know what I mean? Somebody was, doing the energy sector. Somebody was doing something else. But you also had the people in uniform fighting the war, right? So I don't think as a nation we can be segmented or siloed. I think we have to, it's got to be holistic. And that's
okay. All right. Now, this term has come up already. I think Brendan said it, but Keith, you said it off camera. Experiment as a service. Can you explain what that means and how it accelerates rapid prototyping for national defense missions like the simulated ones at Cyber Fortress?
Well, so experimentation as a service is a concept that we have put together really in order to show that the cloud is important in real world kind of edge locations. And so we have really a team that works with our partners like GDIT to kind of envision and instantiate unique capabilities like Dogma and bring that to fruition for success, right? And so in reality, experimentation as a service is to kind of help people think outside the box about what you can do with AWS. It's not just about hosting enterprise applications. It's about impacting mission wherever that occurs. And mission is not just a DoD thing. It's a business thing. It's education has a mission, right? And we want to be there impacting mission wherever that occurs. And that's what encapsulates experimentation as a service.
I feel like you want to say something.
Well, I just want to give a shameful plug. I mean, when I think of the words experimentation as a service, it's where, especially within AWS, the questions of, what if and why can't we, right, all begin. Every experimentation begins with something like that. It's like, okay, well, why couldn't we do that, right? And we have an avenue to do that, to develop the art of the possible. And that's a shameless plug to GDIT. But that's the power of the relationship we have with AWS is, we challenge assumptions and, we deliver on those. And that's what experimentation as a service means to me and our relationship to AWS.
I love that tagline. What if and why not?
Yeah, why not? Yeah, tap your inner toddler,
Yeah, I can add it from Cyber Fortress. Like that's exactly what kind of how we wanted to set it up. This is the place to fail. Try your wildest idea that you would never try on the real network, right? And we've been able to do that. And also because we ran it on AWS, we actually saved the entire Cyber Fortress. We have it saved as an infrastructure, as a code. So to give you a little bit of what follow-on has happened, all these organizations kind of followed up and they said, hey, can we get a copy of it so we can rerun it for their own soldiers, their own airmen. And there's a combatant command, AFRICOM, actually reached out. So one of the issues they've been having, because they train with so many, African nations like Tunisia and Morocco, some other ones, they've never been able to find a solution where they don't have to rebuild everything from scratch. And we said, well, take this, run it. You know what I mean? Nobody will know. There's no human being.
It's okay. Borrow it.
Okay, borrow it. But think about the impact. Now we can run what if scenarios, not just in the United States, but with allied partners all over the world.
I love that. And I also love borrowing and reusing. That seems like a good trait in these times. So Andre, I want to stick with you. What would you say to other agencies or partners who are considering a proof of concept with AI in cyber or infrastructure operations? Give us your best advice.
Yeah, so my advice is definitely go out for it. You miss 100% of the shots you never take, right? So, what I'll say is over the years and decades of being in research and kind of acquisition in the military, I only succeed probably about 25% of the time, right? And if you ever, there's a great book, it's called The Intelligence of, or The Psychology of Money, and it's more about the psychology than money piece, but nevertheless, it talks about people who, for all logical reasons, they should have quit, but maybe they were just too tolerant of pain, or maybe they're just too naive.
They just stuck it through.
But they stuck it through. And interesting enough, the success rates of the most successful people is only like 30, 40, 50% at best. So, but if you only try 10 times and you succeed 3 times, okay, that's one thing. But if you try 1,000 times and you succeed 300 times, so the rate of success is the same, but the number of victories is much bigger. So my recommendation to everybody, don't be afraid to take that shot. It might be the craziest idea ever. It may work, but you will learn something from it.
And on AI in particular, the return on AI is not linear, right? It's not as good as anything, not as good, whoosh, and then it all of a sudden is 10 times better. And so you never know where that inflection point is going to hit. So if you could be giving up right before the inflection point, don't give up.
I like keep up. It's perfect. It's all about finding that aha moment in your tools. Like you're learning the tool. Aha, I figured it out. All right, awesome. So if we fast forward to Cyber Fortress 2026, what capabilities do you hope to see fielded? And what barriers do you think we still need to overcome? Keith, I'm going to pick on you first.
I like going national. I like having, including more like scale. Let's, do 10x. Let's like really scale this. And I think we're ready to go for that. Love to see even more AI tooling, pulling in more data, maybe, and even some more use cases beyond, the power industry, other industries that we want to work with, pulling all those in. But AI.
Brandon.
Yeah, again, all in on AI. I think for me, it's really scale. We've done this in very isolated pockets, and you've had sensors that have been aggregated in one exercise in one little area. I want to see federation at the national scale, where we're integrating sensors at the entire national scale that can then be viewed anywhere. And then at the same token, being able to federate out the visibility into what that looks like. And then from the micro tactical grid perspective, being able to have reach back and failover. So, you're not always alone on the battlefield. There's always someone watching over you. And, at a national scale, that could be someone on the East Coast watching over something on the West Coast, and the West Coast goes down. And you still have to be able to work through things. And I want to be able to push and pressure test that failover and that redundancy.
Your thoughts?
Yeah, and then from my perspective, I really definitely want to see federation of sensors. That is extremely important. I definitely want to see larger. We'll try to get to 10x by next year. We'll kind of see, but also multiple domains. So this year we've introduced a UAS, counter UAS, operational energy. We had the cyber domains, right? But like there's other things out there, physical security. You can have the best cyber defense. If somebody breaks through your wire, your fence, your cyber only goes so far. So what we do want to bring next year is we have AI-enabled robots for patrolling, right? We want to have sensors that could maybe potentially deploy on a UAS and monitor. We're thinking about these things. What is the whole package? How do we protect on the physical side, also on the cyber side, on the digital side, counter UAS side, this entire domain? And one of the conversations we're having right now with one of the federal agencies that operates in space, I'm not going to name them, but they're saying, what about space communication? And we're like, yes.
Of course.
Why do we think about that? And it's interesting because of the Kuiper program and the Starlink. If somebody this is actually something I learned recently. If you compromise the terrestrial system, you can actually push corrupted packets up to the satellite, which then breaks the digital system. And nobody ever thought of this because, like how often do you touch a satellite in space? There's not.
Me never.
Yeah. It's not something that you do regularly. But now
We've thought about it.
Oh,
Okay, you thought about it.
yeah. So now let's think about that too, because you corrupt the communication system. Well, you just took the federation of sensors or the cloud connection, and you really does it. So we're thinking about this multi-domain, in all domains.
I like it.
All right, so I'm hearing scale, federated sensors, multi-domain environment for next year's Cyber Fortress. So that sounds great. Gentlemen, you've been amazing, but believe it or not, we have come to the end of our time. So from the edge to the enterprise, Dogma and AI-driven solutions are helping defense teams outpace adversaries, anticipate threats, and make better decisions more quickly. To our guests from GDIT and AWS, and of course, the Virginia Army National Guard, thank you for sharing your insights. And thank you for tuning in. And until next time, stay secure, stay informed, and stay connected.